Hi everyone, this is Darren here, and today I'm going to be covering again on algebraic fractions. What happened specifically, I'm going to be looking at those with divisions inside. So without further ado, here's my first example. So suppose we have 2 over k square divided by 6h over k square. Okay, this is a simple example, but the first important thing to note is that when we see a divide and in such a way, we are able to actually change this divide to a multiply. And when we change a divide to multiply, we will flip this. So therefore, this can also be rewritten as 2 over k square multiplied by k square over 6h. And now, having rewritten it like this, it is clear that we can actually just cancel this and cancel this. So therefore, again here and here we can cancel, because 2 can become 1 and the 6 here can become 3. So therefore, 1 times 1 giving us numerator of 1, and the denominator will be 1 times 3h, so giving us just 3h. So therefore, this would be the answer. Alright, so this is simple enough. What if it gets more complicated? If there is more confusing terms and powers involved. Let's see what happens. So in my second example, let me illustrate that. Okay. So in the second example, suppose we have m plus n over n square. This will be divided by 2m plus 2n over m squared times n. Okay. So actually, I would like to say the first step for this type of division questions, algebraic division, is always simply to change the divide sign to a multiply. And when we do that, we have to flip these two. So therefore, this will just be rewritten as m plus n over n square multiplied by m square n over 2m plus 2n. Okay. So now one thing to take note is that if you look at these two, actually they are similar. Why are they similar? Because I know that I can pull out a common factor of 2. So in this type of questions, we always have to look out for common factors. Because now if I pull out this factor of 2, this will become m plus n, and then these two will have a common factor, which is just m plus n, right? So let me rewrite that once again. So this will be just m plus n over n square multiplied by m square times n over 2 m plus n. Okay, so this is quite clear. So now we see that these two are the same, and therefore we can cancel them out. So I'll just go ahead and cancel them out. And here we have an n square and here we have an n, so I can cancel one n out here, and I cancel out the square here. So this just leaves us with, the numerator will be 1 times m square, and the denominator will be n times 2. So therefore, our final answer will just be m square over 2n. Okay, so let's move on to a third example now. Okay. So in this third example, suppose we have 7a square b cubed over a cubed divided by 14a times b square over ac square. Okay. So can you recall what's the first step always? Okay, so the first step is always to flip the divide sign. So go ahead and do that. So what are we left with? So it becomes this multiplied by AC square over 14AB square. Once in this form, we can go ahead and start cancelling. So good. One thing I see is there's A here and A here. So very clearly, I can do a simple cancellation here. And here, A square and A cube. So I'm going to remove this A square and just make this a A. And now, likewise, I'm going to do it for the B. There's a B square here and a B cube here. So B cube divided by B square just gives me B. So therefore, I'll cancel out the power and cancel out the B square. And now, what else? The A is settled, the B is settled, and the C, there's no other C to cancel out. How about the numbers 7 and 14? Yes, they are actually multiples of each other. So therefore, hence, let's just cancel this out too. I'll make this a 2 and I'll make this a 1. So this is just going to be 1B. And 1B, there's no point to write 1B. So I'll leave it as B. Therefore, the numerators will just going to leave us with B times C square over 2 times, over A times 2. Therefore, this will just be B C square over 2A. Yes. But one thing you have to take note is that when you're going to do cancellation like this, you have to be very careful that you do not cancel out the wrong thing, or when you multiply, although it's simple, that you miss out multiplying one of the terms. Okay, so I'm going to move on to even more complicated division, algebraic divisions. So please follow along. Okay, suppose we have this question now. For m plus n square over 3m square, and this gets divided by, okay, let me just erase this since I need more space for this question. Okay, so divided by 6mx plus 18nx over mx square. Okay. So yes, this may look complicated to some of you, but always recall the basics. So I'd say that the first step when you encounter algebraic division is to always make it algebraic multiplication. So we're going to flip this divide sign to multiply. And we go ahead and do that, and what do we get? 4 m plus n square over 3m square multiplied by mx square over 6mx plus 18nx, right? This is okay, it's fine. So now let's see. I see this m plus n square here, and I'm now looking out for, is there any, is one of these terms, can I pull out a factor and have it similar to m plus n? I could, right? You see here? There's an m and there's an n. So if I were to actually pull out 6x and 18x, would I be getting something close to this? Something to think about, right? Let's go ahead and try. Let me rewrite this as, okay, I'll rewrite this left hand side here. Times square so I pull out 6x here. This gives me m plus 3n. Alright, so take a moment and realize, hey, these are different. So this is actually a problem, right? You can't just go ahead and divide because they are very different. This is m plus n and this is m plus 3n. But okay, fine. So we know that we can't simplify here. It doesn't mean that we cannot solve this question. We still can. We just have to focus on the other terms. So let's see. This x here and this x here, right? So let's go ahead and cancel that out. So cancel this out. And this will just be, remove the square. And here, m square, I'll just cancel out and remove a m. Okay? Then I look at this. I see that, alright, it's looking complicated, and I want to write this down in another step. I don't want to go ahead and just start cancelling all from here. Okay, I want to rewrite another step. So I'm going to rewrite it on top. Okay, so let's see what happens. I'll rewrite this step on top here, and let's see what we have. So it's just going to be equals to 4 m plus n square over 3m instead of 3m square multiplied by x over 6m plus 3n. I'm just rewriting it so we can restart from here. And now, okay, let's see. There's not much cancellation we can do, right? Because this is m plus 3n and this is m plus n. So let's just go ahead and multiply and see what we get. So the numerator will be this times x, so it just gives us 4x m plus n square, and the denominator will just give us 3m times 6, giving us 18m, and then m plus 3n. Alright, so yes, we have simplified actually, and this is as much as, although it still looks difficult, but this is as much as we can simplify, and this is as much as we can go. So therefore, in cases like this, where the question chooses to be tricky, because we cannot cancel these two, we have to just leave it as quite a big chunk here, and that'll be fine. Alright, so okay, take note of this, and we just move on to my last example. So in my last example, it's also very tricky, so again, please watch carefully. Okay, so say we have 3mx minus 3my plus n. Okay, I think I'm writing it too big. Let me write it smaller, because this is a long question. So we have 3mx minus 3my plus nx minus ny over x plus y divided by mx plus 2nx minus my, okay, and minus 2ny over 3x plus 3y. Alright, so faced with this question, again the first step will still be the same. It looks really complicated, but okay, ignore that, just focus on this divide. We hate division, okay? So let's make it multiplication. Okay, so let's see what happens. I'll flip it, and now we get 3mx minus 3my plus nx minus ny over x plus y. This gets multiplied by 3x plus 3y over mx plus 2nx minus my minus 2ny. Alright, so straight away, now that we've made it into the multiplication form, we can see that there's x plus y here and x plus y here, and if I pull out the 3, they will have the same factor. They'll be the same, right? There'll be 3 times x, it'll be like this, 3x plus y. So I'll take note of this. So this much here is pretty much settled. So let's see now for this part here. This part here looks complicated, right? But let's see, we have a 3mx minus 3my, and here we have mx plus 2nx. So instead, let's have it in the same form, right? Let's put mx minus my plus nx minus ny, okay? So I'm not going to rewrite another line, but I'm just going to change it here. What I'm going to do is just flip these two, okay? I'm going to put minus my here instead, and here I'm going to put plus 2nx, okay? Plus 2nx. So now it's very similar, right? mx, my, nx, ny. Okay, that's good. So let's see. I'm going to do the next step where I'll start factorizing out. So let's see what we get. Okay, this will just be if I pull out this, I get 3m x minus y plus n x minus y over x plus y. Okay, so allow me to fully elaborate on this step. Okay, as I know some of you might not be able to follow, but let's take it slowly. Okay, what I've done, 3m times x. Doesn't this give us 3mx? Yes, it does. And 3m times negative y. Does it give us negative 3my? It does again. So therefore, this part here is actually we're just rewriting these two into this. Okay, and this part here, the same, n times x giving us nx, n times negative y giving us negative ny. Okay, so now let's look at the denominator here. We're going to do something similar, and here, as I said, I'll just pull out the 3, giving us x plus y. Here, and denominator will be just I'll pull out the m, I get x minus y, and here I pull out a 2, so I get plus 2 x minus y again. You see, because 2 times x is giving us, oh sorry, I should pull out 2n, not just 2. So 2n times x is giving us 2nx, and 2n times negative y giving us minus 2ny. Okay, so it's good because there's negative xy here, x minus y here, x minus y here, x minus y here, x minus y here. So they're all the same. These 4 terms are the same. So it's really useful to solve this question. And now, let's see what happens. I'm going to rewrite it on top again. And we get as such. So this will be equals to, I can rewrite this, right? I'll just say 3m plus n x minus y. Okay, so this is a really important step to take note that we are able to do this, because here we have x minus y and here we have x minus y. So in a way, x minus y is being multiplied with 3m and y, right? So x minus y is being multiplied by both these two terms. So I can also rewrite it as such. And now this will just be x plus y, and this will be times 3x plus y over m plus 2n x minus y. Okay, you see, it's starting to look easier now, right? Much more easier than at the start. But so with our diligent steps and taking it slowly and carefully, we're able to move forward with the question, and we're definitely getting it simpler and simpler, and we're close to solving. Okay, so let's see what happens. Now x plus y, I just go ahead and cancel. So this leaves me with 1 here in the denominator. And here x minus y and x minus y, we cancels off simply. And more or less, this is as far as we can cancel out and simplify. So therefore, we just have to multiply the terms and write it down as the answer. So this will give us to 3 times 3, sorry, I just multiply it in. 3 times 3m giving us 9m. N times 3 giving us plus 3n. This will be 1 times this, so it's just this. So we just m plus 2n. Okay? And therefore, this will be our final answer, because we are not able to factorize anymore. We can't pull out the m and n, because why? Let's see. It's not possible, as these two if maybe if let's say this was 1.5 m, right? If this was 1.5 m, we could simplify one more step, okay? But it is not. Because if it was, we could just, what would happen? You see, I can pull out one. If this it was 1.5, I can just say this is 1.5 m plus 2n over m plus 2n, right? And then these two just cancel out, becoming 1.5 is the answer, but it's not. And so there will be no more factors that are similar, no more terms that are similar for us to cancel out, and we have to just leave our answer and our final answer as such. So this is our final answer. I hope that you managed to follow this example along, especially because this was the hardest one, and I believe it was the most illustrative. So with that, I'm happy to close off this video. I hope you enjoyed and learned something, and as you always, please like and subscribe. Thank you very much.